So I have a thought experiment for you. I give you a coin and ask you, what's the probability of flipping heads? Of course, you know the probability is 1/2, but I want you to convince me of that. So intuition might tell you, okay, let's flip the coin 10 times. Maybe say out of that, 7 times come up as heads. So you estimate the probability as 7/10. It's not quite 1/2, and it's not a very convincing argument. But you could flip the coin 100 times, 1,000 times, 10,000 times. The more you flip the coin, the more accurate estimate would be, and the more convincing your argument. So this is an example of a Monte Carlo method. You're estimating the probability of an event as the average number of times that event happens. The same principles can be applied to much more difficult problems. For example, the Earth's magnetic pole actually undergoes reversals occasionally. What is currently the North Pole might have been the South Pole at one point. These reversals occur every 200,000 to 300,000 years, and it only takes 100 to 1,000 years, roughly, to flip. So if we were to ask the question, like, what's the probability that there's a reversal in the next 1,000 years? So you could, well, it's not quite as simple as flipping a coin. You can actually run numerical simulations, and you can count the number of times that the reversal occurs in your simulations and divide it by the total number of simulations that you made. So that gives you an estimation of the probability. So now the difficulty with this particular example is that the probability of there actually being a pole reversal is very small. This is something that we call a rare event. You could simulate this 1,000, 10,000 times, and you might never see it happen. Now, since Monte Carlo methods, their accuracy depends on the number of times you actually see the event happen, it becomes very difficult to get good estimates. So what I study in my research is a way to tweak kind of the mathematical models that you're using such that these rare events are more likely to occur. And then you add in a term at the end that corrects for the bias that you introduce and ensures that you're actually estimating the correct probability. And I'm developing the methods for asserting class mathematical models, and I'm demonstrating that they can actually improve the accuracy of your estimates substantially.